the repair and or refurbishing or restoration of the Marantz had to be paused last time, so a few weeks ago, because I simply lacked the necessary parts to be able to continue with the restoration, right? And what were those parts? Well, first of all, the replacement motor. So I had to order a new motor for the cassette mechanism, which not only plays cassettes but also records them. Okay, simply because the original motor, so this one here, was not good anymore, in the sense that it was noisy when it ran. So there was a very audible buzzing in the mechanism. So yeah, the motor is probably shot. Now, unfortunately, or fortunately, depending on how you look at it, in my clumsiness, I dropped the motor and I broke off the connecting lip you see here. Yeah, so normally this motor has 4 connector lips right there. Yeah, and unfortunately I broke them off in the original motor, because like I said, in my clumsiness I dropped the motor. But then again, it's of no moment, because this motor was spent anyway. I mean, like I said, it gives a sort of a growling noise when I run it. So I'm pretty sure it's used up. So what I need to do is to transfer the pulley on the original motor, which is this black little thing here, to the new motor over here, okay, before I can mount it back. Now, the other parts that I was waiting for was this little tape tensioning wheel, okay. So, and it's a semi-hard rubber, but it's still very pliable. It's still bouncy, okay. So it can be compressed and it will come back in its original shape. Now, the original one, so this is one of the original ones, is very, very hard. Yeah, it's you can almost not compress it. You know, it's rock hard. So I had to find a replacement wheel, right? And well, this is it. You know, so the right one is the new one, okay, and the old one is the black one, right? Now, while I was waiting for these, I had some trouble finding the specifications of the axles that have to go through this little wheel here. And I'll be honest with you, I actually lost track of the original axles. Now, there's not a big problem, because after some long and hard thinking, I realized I had actually the solution. And the solution I found is this. So when you have a wristband for your watch, your wristwatch, okay, we all know there is kind of like a little, well, pins at the end, right? So it's compressible at the ends. Yeah, it's a little bit like you could say like a shock dampener of a car, you could say. right? So I remembered I had these here, yeah. Apparently they're called spring bars, okay. So, and they're stainless steel. I had an epiphany that suddenly these might actually work quite well as axles for the little tensioning wheel, yeah, for the cassette player. And indeed, when I choose one, and let me show you, I'll give you a close-up. Okay, so this is a 10 millimeter length spring bar, and there it goes. Yeah, it fits perfectly into the wheel, in fact, in the tensioning wheel of the cassette deck. Yeah, and there's hardly any play in it. And there's just a little play in it, but not much, and it rolls easily around that pin, right? So in fact, that's exactly what I did. I replaced all the pins and wheels, the tensioning wheels of the cassette deck mechanisms. So there, you see here, this is one of the new wheels with one of the pins, the new pins that I installed. And since those pins are stainless steel, they will never ever rust. Also, one of the reasons why I used these pins, well, one of the reasons why I used these pins as axles for the little tensioning wheels is because, let's face it, if these spring bars are strong enough to resist the pull every single day of the wristband around our wrists, every single day, day in, day out, if they are strong enough to resist this pull every day, yeah, then I'm fairly certain that they are resistant and strong enough to serve as an axle for the tensioning wheel of a cassette deck. So yeah, there you go. The size of the pin that I used is, let me see, oh yeah, is the 10 millimeter pin. I don't know if I could show you close up, but there. Okay, 10 millimeter in length, of course. Their diameter, I have some calipers here. So it's in millimeter, okay, not in inches. So okay, so the thickness, or the diameter if you wish, of those pins is 1.4 millimeter. Okay. Yeah, the display is blinking because the battery is near its end. The diameter of this spring pin is 1.4 millimeter, and the hole of this little wheel here is rated at 1.5 millimeter. Okay, so there's a tiny little bit of play, but really not much. The size of the wheel is I'll show you. The outer diameter is 10.1, yeah, around 10.1 millimeter, and the width is almost 7 millimeters, yeah, 6.97 millimeter. So yeah, I bought these wheels, these tensioning wheels, in a batch of 10, okay, and they weren't too expensive. I think I paid them something like $10 or so for 10 of those wheels. Okay, free shipping, by the way. So yeah, there you go. These stainless pins, you know, these stainless steel spring bars for watches, yeah, wrist watches. I don't know how much I paid this, but it probably wasn't that much. So next I need to remove carefully the pulley from the original motor. Okay, so I took off the back of the motor just to satisfy my curiosity, first of all, and second, to see if there is anything serviceable inside, and which of course there isn't. The only weird thing at the back of this motor here is this little copper coil, you know. So there's some foam behind the back of the motor. Okay, there's some foam and a little copper coil, and this copper coil is normally located over this chip here, over the back of this chip. Now I'm wondering whether they intended this copper coil to be sort of like a heat conductor, maybe, to transfer the heat from the power transistor or chip there to the outside case of the motor. I don't know. It's a bit weird. Either way, and I can't imagine this to be extremely effective, but there you go, that's how they did it. And I also had a look at the inside of the motor print board, and yeah, I tore it up quite badly, unfortunately. Yeah, I mean, it's probably still somewhat usable for other purposes, but for a cassette deck, no. So yeah, I need to remove the pulley without breaking it, and then I need to transfer it to the new motor here. Okay, so to remove the pulley from the old axle, all you need is a flat little screwdriver like this, and you need to insert it between the pulley and between that metal lip you see here, you know, of the motor, and you slide the screwdriver between both, and you use the metal lip of the motor as a cantilever, yeah, and you press the screwdriver down on the one end, and you keep a finger over the pulley like this, and there you go. Here's the pulley. Alright, so that's how you remove the pulley from the original motor. And now all I hope is that this will fit the new motor, right? So I hope the axle of the new motor will fit inside the pulley. Remember, it needs to be a press fit. I installed 2 new rubber belts on the mechanism, and obviously I placed back the replacement motor you see there with the accompanying pulley, which I mounted at the bottom of the motor. You see it there, right? But it also turned out that to install the rubber belts, and specifically the small rubber belt you see down there, that it was much easier to do if I temporarily removed this little print board here. Yeah, and I did that by unscrewing 2 tiny screws you see on the print board. Let me show you. So you see 2 tiny screws, one here and one over there, and I also had to unsolder a actuator which was soldered to these 2 points you see down there, right? These 2 here. Still need to clean up a little bit, but yeah. So I had to unsolder these 2 and then lift the whole print board carefully up and away. It turns out to be, well, maybe not a huge lot easier, but certainly quite a bit easier to install the 2 rubber belts with this print board out of the way. But yeah, I had to unmount it, and I had to do it especially carefully because you see these translucent contact switches here, yeah, and these are all attached to this board, and they are incredibly brittle. So just a little bit too much force one way or another and you'll break them off, and then yeah, well, then a lot of pain and teeth gnashing afterwards, right, to try to repair it. So I was careful and I placed it back quite horizontally as it should be, you know, and yeah, there you go. New belts, new motor, all cleaned and greased as it should be. So now this mechanism is ready and the other one is ready as well. I can place them back to the front panel of the cassette deck, and then we can move on from there. The first 2 buttons that I need to place back on the front panel are the cassette eject buttons, which are these 2 large ones you see here. Okay, so these buttons need to go in first. Then there's this little button here which is used to set the sensitivity of the microphone input, right? So yeah, that will be the next one. And then there are these 3 slider buttons. There are 3 of these, like this one here. Okay, and that needs to be mounted back on the command panel right at the bottom here, these 3 buttons here. Alright, so give me a moment to install all the buttons, and then I'll give you an overlook of where I installed them. So basically the buttons need to be installed here in these 4 openings here, and then the eject buttons, there's needs to be installed here. So one here on the right and another one on the left. Alright, so the eject button looks like this, okay, and it has a little lip at the top, you see it there. So the button needs to be placed into the front panel in this direction with the little lip up. Before I mount back the slider buttons on the front panel module, so this module here, I'm going to give the slider switches, which are these ones, these three here, a little spray of contact cleaner. Okay, so that way I know the contacts are clean, and I won't need to open it all up again to clean the contacts, right? Mounting back the button for the microphone sensitivity potentiometer is very easy. You can see here that the shaft of the potentiometer has been milled with a little slot, right? And the button fits really only in one way over this slot, so it just slides on like this. Alright, to mount back the display and button panel to the front panel, you need in all 11 screws. So 9 screws for the display and the button panel. Yeah, and don't forget there is one screw hiding behind the flat ribbon here, the ribbon cable here. So there's one screw there, and there are 2 more here at the bottom. Okay, so 9 screws in all for the front panel, and then 2 more screws for the microphone board, you see right here. Also, when you tighten the screws, you don't need to go overboard, okay? Just make the screws fit tightly, I mean snugly, but not overly tight. The on-off module, or the on-off button if you wish, or like they call it, the standby module, which is this little board here. This standby module needs to go in the far right corner down there, and it's held in place with 1 screw, and you see the post where you need to screw it to. And all the screws, by the way, are standard format Phillips screws, like this one here. Alright, so it's just a standard screw like this. Alright, so you can't be wrong. There's only one type of screw to use, and you need to mount this little board back into the front panel, and there's only one way to mount it, because you see this slot here in the board. This has to fit over a little tab on the front panel. Alright, both cassette mechanisms are built into the front panel again, and the other little boards as well, you know, like the microphone board, which you see there. Okay, and then the on-off button board buried down there. You can just about see it down there, right? So, and then of course the display board and the you know, the button and display board is also mounted back. Now I have a little confession to make. I had to unmount the display board, well, the both boards you see there, again, because I had to connect the on-off wire you see there, you know, the red and white wires which go to the on-off button. I had to connect the connector to this board here, you see, there. So yeah, I probably could have put back the connector without unmounting the button board, but I thought it was just, well, more prudent to unmount it to see whether I'm mounting the connector in the correct direction or not. So yeah, I just took the effort to unmount it all just to hook up the on-off button correctly, which I did. Now I did not mount back the bezel, you know, you could say the front panel that makes it all pretty and with the legends on it and etc, etc. Neither did I mount back the cassette covers yet, for the very simple reason that I want to test out the mechanisms first. I'm going to test the cassette deck as a whole by reconnecting the front part of the cassette deck to the main board you see down here. Now this is only a temporary setup, of course, but I am taking great pains to check all the connections and to connect the metal parts of the cassette decks at the front with crocodile leads to the ground of the main board, right? You need good grounding for everything. Also, I'm checking all the connections that go to the main board twice, and I'm also going to reconnect the ribbon cables that go from the front panel to the main board. There are two ribbon cables, well, there's actually one from each cassette deck mechanism that looks like this, and that goes to a connector like down there. Okay, so these connectors are quote-unquote relatively simple in the sense that they have a very simple locking mechanism. You can pull up the upper edge, yeah, which basically unlocks the cable, and then you can slide in the flat cable with straightened pins into it to lock it into place. And you have to take a certain amount of time to make sure that all the pins are straight, and I mean like really ramrod straight. Okay, so you can't even diverge by half a millimeter, but once they are straight, you can slide in the ribbon cable like this, just like that. And once the cable is in place, all you need to do is to press down this locking mechanism here to lock the cable into place like that. Okay, that's how you do it. And then there is one large ribbon cable which goes from the front panel to the main board, and this is its connector. Okay, so I cleaned it out with contact cleaner, and all I need to do is slide it into this edge connector you see down there. Now I need both my hands to do it, so give me a minute to set the camera on the tripod, and then I'll show you how I do that. Obviously, when you're going to slide in this edge connector, well, this flat cable into its edge connector, you need to be rather careful, okay? Because they may not look like it, but these contacts you see here are really very, very sensitive to mechanical deformation. Yeah. So in essence, when you want to slide them into place, you need to do it really gently and with only just the right amount of force. You know, you really don't need to put a huge amount of force on it, you know, because otherwise you'll damage it, obviously. So here we go. There you go. And you make sure that it's seated correctly, but once it's seated correctly, like that, there should be no problem. Alright, so what else did I do to the main board? Actually, basically not that much. I did mount a fuse and fuse holder to the AC input because, you know, I know a lot of manufacturers skip this, you know, just to save a few pennies while you know, while manufacturing their appliances, but really, safety wise, you shouldn't skip on a fuse and a fuse holder, right? Also, I replaced these two main capacitors here of the power supply. You know, this in effect is the power supply part which supplies the plus 5 volts DC for all the chips. Okay, I unmounted these two, I tested them, they didn't test great, so I thought, well, you know, now that I'm inside, so to speak, the whole mechanism, I could just as well replace these two capacitors to make sure that they function correctly. And I also mounted a heatsink to the 5 volts DC regulator down here. Okay, so I think you can just about see it. So right here. Alright, and that's also one of the things where manufacturers often will skimp, namely not mounting a heatsink when they deem it not essential. You know, but you know just as well as me that any part which heats up and has a tendency maybe to overheat sometimes due to use will break down way faster, right? So I thought, yeah, for a few cents, you know, why not just mount a proper heatsink to the 5 volts regulator, which I did. So basically what I am going to test is whether, of course, the whole thing just works as it is, which means of course all the voltages are there, all the mechanisms, the Cassettedeck mechanisms work, and by work I mean that they just run. So you can rewind, fast forward, record and play cassettes, and if all those basic functions are okay, then we know that the Cassettedeck will probably run correctly. Now there's one thing that I might do also while it's out here, the whole thing. is to set the speed, the running speed of the drive motor I replaced, you know, this one over here. But yeah, that's about it. That's what I'm going to do. And of course now comes the test that we all know as the Big Bang test, right? So basically what I mean by that is we're going to plug in the cassette deck and see whether anything goes bang. Alright, I plugged in the cassette deck into an extension block, which is off for the moment. So what we'll do now is is switch it on and see if everything will work the way it should, right? So let's try by putting power on the connector first. So here we go. Oh yeah, look at that. Okay, well, okay, the display seems to work. Okay, the cassette deck mechanism seemed to work. Well, at least the loading mechanism seemed to work. Alright, so let me grab a cassette and let's see if we can wind and rewind the cassettes, right? Alright, to test the basic mechanical functions of the left cassette deck, I'm going to use a commercially recorded cassette, which I know is damaged, but I mean to try out the mechanism, this will do perfectly. Alright, now I haven't figured out just yet how to, if both cassette decks would have a cassette, how you would switch between them. I rightly don't know, so I need to find that out. But okay, so let's try the left mechanism first. So you put the cassette with the tape end first into the tray like this, and you close it up, and okay, and once you charge it with a cassette, the symbol A goes on the display there. Let me show you. So I inserted a cassette into the left cassette deck, which is labeled as cassette deck A, right? So and on the display the letter A appeared right there. So if I unload the cassette and I close the cassette deck, you see nothing appears here. So but when I load the cassette, the letter A appears. So which means that the cassette deck apparently seems to detect that there is a cassette in the cassette deck. Alright, so let's see, can I fast forward the cassette? Yes, I can. Okay, and I can stop. Now let's see, can I rewind it? Yes. Yes, I can. Yes, I can. Okay. So the stop button works and everything seems to work. Let me see. There's a reset button here, so I think this reset button will reset the counter for the cassette deck. Let's see. Yep, that's exactly what it does. Okay, so what I'm going to do next is I'm going to fast forward and rewind the cassette completely as a test, for the auto stop. And once I'm done with that, no need for you to stay around to watch me rewind the cassette. We'll do the same kinds of tests with the other deck. Alright, I tested the rewind and fast forward of this mechanism, and it works flawlessly, as does the counter, by the way. So let's see if we can reproduce the results with the B drive, right? Let's insert a cassette. Well, the sensor says there's a cassette now in drive B. That is good. I reset the counter to 0, so let's see if I can do some rewind. Okay, it was already rewound, so let's do fast forward. Ah, yes. Yes, yes, yes. It is rewinding, or fast forwarding, I should say. Okay, same thing. I won't keep you hanging around watching me fast forwarding and rewinding the cassette on this one. I just want to test out the mechanism and the auto stop function, right? So once I'm done with testing that, I'll bring you back. Alright, checking the rewinding function. There should almost be, and there we are. Okay, so the rewinding function tests nicely as well. Okay, so basically I tested out the basic mechanical functions of both cassette decks, fast forwarding, rewinding, ejecting, auto stop, the counter, etc. These things seem to run properly, so I think maybe the moment has come to see whether it'll work sound wise, right? But to test that out, I need to connect the cassette deck obviously to an output, to an amplifier, let's say, and so that's what I'll do next. Alright, I inserted a cassette in drive A. Yeah, obviously I'm not going to let you hear a whole song, unfortunately, because, well, I don't want to get a copy strike from YouTube. But if you're interested to know which cassette I'm using to try out the cassette deck, is the cassette Eroica of Wendy and Liza. Okay, they used to be the backup group for Prince, actually. Very good musicians, and I really love their music. So if you're a Prince fan, you're certainly going to like this cassette or this record as well. Eroica of Wendy and Liza. So here we go. The cassette is ready, so let's switch on. Oh, keep in mind I'm using some very cheap computer speakers, okay, so let me show you. So I'm using a pair of very cheap computer speakers to test out everything, well, mainly because it's convenient, and two, because I don't want to flood the room with really deep sound, you know, like noise, because it's already quite late. It's almost midnight over here, and I don't want to bother the neighbors, right? So yeah, here we go. Okay, that sounds good. So let's fast forward a little bit, because, well, like I said, I don't want to play the whole cassette, but okay, here we go. So it would seem that Cassettedeck A works on both channels, by the way, so left and right. Let's try Cassettedeck B with the same song, by the way. Come on. Okay, here we go. Oh, let me fast forward a little bit. Yep, it would seem Cassettedeck A and B play, and you know what? I'm very surprised actually that Cassettedeck B, you know, is where I replaced the motor, seems to sound quite good actually. So I mean, that would be an enormous stroke of luck if I wouldn't have to change the speed of the Cassettedeck, right? But I mean, this is only a preliminary test, okay? I just want to see whether all the elementary functions of the Cassettedeck work or not. Because obviously if some big problem would surface now, then that would mean the project is either dead in the water, or I need to figure out what else needs repair. Okay, but so far so good. Everything seems to run properly. I've also tested with the famous finger test whether any parts are overheating, mainly in the power supply, and everything seems to be of normal heat. Yeah, it's lukewarm, it's barely warm, you know. So the parts are not overheating. Everything seems to run normally, including the display and of course the motors. I would say, yeah, the operation succeeded. So I think before I start calibrating the Cassettedeck, what I'll do next is mount everything back into the case, right? Because as it sits here, it's really very exposed, you know. So and I don't like it. It's not very safe, for one, and two, yeah, I don't want to damage anything, because the space in my lab is really tight. So what I'm going to do is I'm going to disconnect everything again and then mount everything back into the case. Well, the beauty of having two Cassettedecks on the same machine, of course, is that you can listen to the cassette on both and compare And right now the way I feel is that the cassette deck, and that's no surprise of course, the cassette deck where I replaced the motor seems to play a little bit too slowly compared to the one with the original motor, so the left one, yeah. So the right cassette deck needs to be tuned a little bit. I mean in speed, in running speed. It's just a little too slow. After a quick perusal of the service manual, I found out that to set the speed, the running speed of the motor with a trimmer, and the trimmer for drive B, so the one which can record and play, is that one over there in the corner. So it's labeled as RM53, the one on the right. Okay, so with that little trimmer I should be able to set the speed of the motor such that the frequency response once it plays is correct. Okay, I'm going to use, by the way, a calibration audio cassette for that, right? So that's for drive B. You have a similar one for drive A. So for drive A, you need to set the trimmer RM03, which by the way is also labeled as N speed for normal speed. Next to it there's one labeled as H speed, so high speed. Now according to the service manual, the RM03 is for the normal speed, so meaning that if you use the calibration cassette, when it plays a sound at 3 kilohertz, it should be within 3 kilohertz with a margin of plus or minus 10 hertz. Okay, obviously the same setting is valid for the N speed of the N speed trimmer of the B cassette drive. Okay, the H speed, by the way, they say you need to use that if you want to trim the high speed running speed of the motor at 6000 Hertz. The same for the A drive. I don't think I'm going to touch the H speed, but I am going to set the N speed RM53 trimmer, more than likely, because I noticed the speed of the cassette drive being slightly on the slow side. Alright, so here's the setup. I have the speakers connected to the outputs of the cassette deck, alright, which are the two left kinch connectors, and inside I have my oscilloscope attached to the right channel output. Okay, so I'm taking ground from the chassis, which is grounded everywhere anyway, and I connected up my probe, my oscilloscope probe, to the right channel output. You see it there. Alright, so by the way, the probe is set on 1x, so one time. Alright, so the settings of my oscilloscope are 200 millivolts output sensitivity, and I'm monitoring the frequency and the average, the peak-to-peak voltage. Alright, the voltage is not that important, but the frequency is. So the cassette mainly has two frequencies that I'm interested in, namely a 3 kilohertz or 3000 hertz tone and a 400 hertz tone. Okay, so the cassette is going to play those sounds, and you're going to be able to watch it on the screen. Okay, and as it plays, I'm going to set the speed, the running speed of the cassette with the little trimmer I showed you earlier. Alright, so warning, noise warning for you people. If you're watching this, maybe you might turn down the volume a little bit, because you're going to hear for at least a minute or two some penetrating sounds. Okay, so 3 kilohertz is really not very pleasant to listen to when it's rather loud. Okay, alright, sound warning for you people. If you're watching this, you will be hearing consecutively a 3 kilohertz or 3000 hertz sound and a 400 hertz sound. Now I need to set the speed of the motor of the cassette deck such that it is by maximum 10 or 20 hertz within the frequency you hear over the speaker, right? So yeah, if you don't like listening to that kind of continuous noise for a while, then please turn down your volume about now, I would say. Yeah, maybe I need to turn it up a little bit. I'm more concerned about the average frequency, okay, rather than the precise frequency, right? So this is the 400 hertz sound. Yeah, I would say this is close to, I would say this is as close as I can get it to 400 hertz. So I'm not going to fool around with the speed controls of the motor any longer. It's running okay now. So what people describe as whoa or flutter, whoa is the change in frequency you see. Yeah, sometimes when it speeds up, the wave narrows, the waveform, and if it slows down, the waveform widens, and that's what they call wow. Yeah, so, and then you have the amplitude of the waveform, so in height, peak to peak, which changes a bit, and that's what they call the flutter. Yeah, which is really changes in loudness, you could say, or amplitude, right? So that's wow and flutter. So I would say the cassette deck is playing rather well. It's within tolerances, you know. Remember, it's about 10 or 20 hertz around the frequency being played. So yeah, I would say on average it's doing okay. Alright, so let's see, I'm going to listen to some music on the cassette deck now, and then I'm going to judge for myself whether it sounds nice or not. Alright, no test could be complete, of course, of a cassette deck without doing a recording test. So I inserted a normal cassette type 1 in the recording cassette deck on the right. So cassette deck B, as you can see on the display. And we're going to record off the digital broadcast. Okay, I have a small digital receiver here, which allows me to receive local digital broadcasts. And yeah, we're going to record a few minutes at most on the cassette. The goal being, of course, to see whether the rendition of channel A and B, or left and right, works well, and I can set the recording volume or recording sensitivity, right? So okay, so here we go. I push the pause button and I push record. Oh, wait, hang on. So now, yeah, I can't let you hear everything I'm recording because, you know, of the usual copy strike danger. So here we go. There you go. Okay, so to set the recording level, you can do it with these buttons here. Okay, so you have the down and the up record level. You know, if I add a little more, you'll see it shows as the graduations at the top of the screen. Alright, if I do a little less, you see the graduations diminish at the top as well. There is an auto setting, but I like to be my own boss where recording levels are concerned. So I like to set my record levels myself. There you go. So we're going to record a couple of minutes of the broadcast, and then we're going to play it, right? I could monitor the recording while while I'm recording it on the cassette. So we're going to go to, say, 150 mark, the 150 mark. So let's say, yep, like this. Now we're going to rewind. Okay, so keep in mind, I'm going to skip a few parts, okay? But we just want to hear whether it records well. Okay, volume. So yes, it records on both channels.
Oké, ik dacht het ding met gebladerte. Oké, dan ga ik voor...
Okay, that is another recording. So, yeah, it seems to record on both channels, and the quality is okay. I mean, the speakers are not very good, but I mean, the setup is just so that I can do a few tests, right? but yeah, I mean, it looks like the recording is just fine. I can do just another recording just for fun. Here we go. Reset. Yeah. Then record.
Een willekeurig woord in de app van M&M. Dan gaan we zo meteen samen rappen tot aan bloot.
Okay, here we go. Yeah, I'm quite pleased with the cassette deck. It seems to work nicely, and I'm also glad that I calibrated the speed of the cassette deck, because it was definitely necessary. It wasn't off by a lot, but I think it was running at a speed that was slightly too slow. Yeah, but now it seems to run just well, perfectly, you know. I mean, as perfect as you can get a cassette deck to run, right? But don't forget, this is a mechanical player, nothing electronic here. Well, not entirely electronic, okay, so it's not an MP3 player. But I mean, for a cassette deck, yeah, it's running pretty well. So let's see now. We're almost at the 150 mark. Okay, now let's rewind. Let me push up the volume a little. Okay, so here we go. Notice that I can switch if I want between fast forward and play or rewind and play without pushing the stop button, right? So and the auto stop works perfectly as well. So here we go, play.
Mislopen, maar misschien gaat het vandaag echt mis. Dat ik rare dingen begin te zeggen, maar help vooral, hè. Willekeurige woorden nu in de app van M&M.
Yeah, I like it. Alright, so yeah, all the functions of the cassette deck seem to work nicely. So there you go. So far for the restoration of the Marantz stereo double cassette deck model SD-535. A great machine. I love it. I've had quite a bit of work making it run properly again, but yeah, the result is fantastic. I really like this cassette deck, and it will allow me to make copies of my cassettes that I use most, namely my calibration cassette, right? So yeah, these things wear out rather quickly, these calibration cassettes, so I'd like to make a few copies of it for my personal use, obviously. So there you go. I hope you liked it. Oh, by the way, I didn't restore the outer shell of the cassette deck just yet, because the weather is really abominable outside. Rain and stormy and cold, and it's really not ideal weather to do painting. But eventually I will get to it, obviously. But I also thought that maybe you might not want to see me paint a cabinet. I mean, after all, I guess it would be too much of a watching paint dry thing, right? So yeah, there we go. The repair and restoration of a Marantz stereo double cassette deck SD-535. I hope you enjoyed watching it, and hopefully you learned something from it as well. And I'll see you all back soon for another episode on my channel. Thanks for watching.